Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side CD equals to 2 units, and we also know that AD equals to CB. Angle DAB, this angle equals to 30 degrees. Angle ABC, this angle equals to 90 degrees. It is a right angle. And we want to find out the area of this quadrilateral ABCD. So we'll start with the first method. And from point D, we will draw perpendicular to AB. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point of the perpendicular from point D to AB as point E. And we also define line segment DA as A, that is to say line segment DA equals to A units in its length. And we focus on the right triangle ADE. On the right triangle ADE, sinus 30 degrees equals to DE over AD. I'll repeat again, in the right triangle ADE, sinus 30 degrees equals to DE over AD, but DE equals to A units according to our definition, so we will substitute DE by A. And it is actually equals to sinus 40 degrees equals to A over AD. We also know that sinus 30 degrees is 1 over 2, so we'll substitute sinus 40 degrees by 1 over 2. 1 over 2 equals to A over AD. So here we will cross multiply equation number 1, and we will get that AD equals to 2A. So we can write here that AD equals to 2A. But it is given us in the question that AD equals to BC. AD equals to BC. And we found out that AD equals to 2A. From this equation we will derive that BC also equals to 2A. BC equals to 2A, so we can write here that BC equals to 2A. In the next step, we will draw perpendicular from point D to CB. So this angle is a right angle, it's equals to 90 degrees. And this angle, it is also a right angle, it equals to 90 degrees. And we will define the touching point between the perpendicular from point D to BC as point F. And we focus on quadrilateral DFBE. In quadrilateral DFBE, we have three right angles, 1, 2, 3. The sum of three right angles is 90 degrees times 3 is 270 degrees. Plus, we define this angle, angle ADF, as angle X. So, actually, in quadrilateral DFBE, the sum of all of its all of its four angles is equal to 270 degrees plus X. And we have rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. I will read rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, according to rule number 1, the sum of the angles in quadrilateral DFBE must be equal to 360 degrees. That is to say, 270 degrees plus X must be equal to 360 degrees. According to rule number 1. And here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees. That is to say, it equals to 90 degrees. Angle X equals to 90 degrees, so we'll substitute angle X by a right angle. You can see from the drawing that all the angles of quadrilateral DEFB are right angles, they are equal to 90 degrees. And we have also rule number 2. according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. So I'll repeat on rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So, because of the fact that quadrilateral DFBE has 4 right angles, we relate to quadrilateral DFEB as a rectangle. According to rule number 2, quadrilateral DFEB is a rectangle because it has 4 right angles. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So it means that in rectangle DFBE, DE equals to FB, DE equals to FB, according to rule number 3. But DE equals to A according to our definition. So we can write down that DE equals to A. And from this equation, we will derive that FB also equals to A. FB equals to A. So we can write here that FB equals to A. And what is the value of CF? You can easily see from the drawing that CF equals to CB minus FB. We'll write it down. CF equals to CB minus FB. I will repeat again, CF equals to CB. You can see it easily from the drawing. So CF equals to CB is 2A minus FB is A. So 2A minus A is A. So we found out that CF equals to A. CF equals to A. In the next step, we will join points D and B by a straight line. And we will prove the triangle DCF congruent to triangle DFB. I repeat again, we will prove the triangle DCF congruent to triangle DCB. So why those two triangles congruent to each other? It is actually triangle DFB. Triangle DCF congruent to triangle DFB. This triangle is triangle DFB. So why those two triangles congruent to each other? First of all, we know that CF equals to FB equals to A. CF equals to FB equals to A. I'll repeat again. CF equals to FB equals to A. We also know that those two angles are equal to each other. They are both right angles. So angle CFD, this angle, is equal to this angle. It is actually angle BFD. And those angles, they are both right angles, they are equal to 90 degrees. I'll repeat again, angle CFD equals to angle BFD, and they are both right angles, they are equal to 90 degrees. And this side, side DF, is a common side, it belongs to both triangles, so DF equals to itself, DF equals to DF. It's a common side that belongs to both triangles. So we actually proved the triangle DCF congruent, this is the sign of congruent, to triangle DFB according to side angle side rule. I'll repeat again. We actually proved that the triangle DCF congruent to triangle DFB according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you have a triangle that has two sides and the angle between them and the angle between those two sides that congruent to two sides and the angle between them in the other triangle, then you prove that those two triangles congruent to each other according to side angle side rule. And we actually proved that those two sides and the angle between them, that is to say this angle in triangle DCF, can join to those two sides and the angle between them in triangle DFB. Therefore, we proved that those two triangles can join to each other according to side angle side rule. And from the fact that those two triangles can join to each other, we will conclude that DC equals to DB, DC equals to DB, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can join to each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But according to what is given us in the question, DC equals to 2 units. So we can write here that DC equals to 2 units, and from this equation we derive that DB also equals to 2 units. DB equals to 2 units. So we can write here that DB equals to 2 units. And in the next step, we will implement the Pythagoras theorem on the right triangle, triangle DEB. Triangle DEB. So according to the Pythagoras theorem, in the right triangle, triangle DEB, DE square plus EB square equals to DB square I will repeat again. On the right triangle, triangle DEB, according to the Pythagoras theorem, here PT is Pythagoras theorem. According to the Pythagoras theorem, DE square plus EB square equals to DB square. So DE equals to A, so DE square is A square, plus EB, EB is the missing variable, so EB square is EB square, it equals to DB square. DB is 2, so DB square is 2 square. 2 square is 4. And we got that A square plus EB square equals to 4. And here, so we got that A square plus EB square equals to 4. So actually EB square equals to 4 minus A square. Okay, EB square equals to 4 minus A square. in the next step, I will present to you a new law that is called the law of cosines, and we will implement the law of cosines in triangle DAB. So, what is the law of cosines? First of all, you should know that the law of cosines is true in any triangle the law of cosines so in any triangle if we have triangle ABC, that could be any triangle, so this is triangle ABC. And we know that AB equals to A units, BC equals to B units in its length, and AC equals to C units in its length, and the angle between side AB and side BC is angle theta. Then, according to the law of cosines, A square plus B square minus 2 times AB cosine theta equals to C square I'll repeat again. According to the law of cosines in triangle ABC, A square plus B square minus 2 times AB times cosine theta equals to C square. Here we will subtract C square and we will also add 2AB cosinus theta to this equation, and we will get that A square plus B square minus C square equals to 2AB cosine theta. So here we will divide this equation by 2AB and we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. So in any triangle, we know that cosine theta equals to A square plus B square minus C square over 2AB. And we can implement the law of cosines in our triangle DB ADB. So I'll copy triangle ADB in a new page, and we will implement the law of cosines on triangle ADB. Okay, so triangle ADB, this is side AB. So this is triangle ADB, and we will implement the law of cosines on triangle ADB. According to the law of cosines, cosine 30 degrees in triangle ADB will be equal to 2a squared plus 4 squared minus 2 squared over 2 times 2a times 4 . We know that cosine 30 degrees is square root of 3 over 2, and it equals to 2a squared is 4a squared, plus 4 squared is 16, and minus 2 squared is minus 4, so 16 minus 4 is 12. So in the numerator we have 4a squared plus 12, and in the denominator we have 2 times 4 is 8, and 8 times 2a is 16a. Here we will multiply this equation by 16a, and we will get that square root of 3 over 2 times 16a equals to 4a squared plus 12. Sixteen over 2 is 8, so we will get here that 8 times square root of 3 times a equals to 4a squared plus 12. Here we will divide this equation by 4, and we will get that 8 over 4 is 2, so here we will have 2 times square root of 3 times a equals to 4 over 4 is 1, so here we will have a squared plus 12 over 4 is 3. Okay, so we got that 2 times square root of 3a equals to a squared plus 3. Here we will subtract from this equation 2 times square root of 3a, and we will get that a squared plus 3 minus 2 times square root of 3 times a equals to 0. So here we know that 3 is equal to the square root of 3 squared, so we will substitute 3 by square root of 3 squared. So it is a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. Here this equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a plus b, a minus b squared, that equals to 0. In our specific expression, a equals to a and b equals to the square root of 3. So we can substitute our expression by a minus b squared according to this algebraic identity, we will get that a minus b squared, it is actually a minus square root of 3 squared. That will be equal to 0. So here we will take a root out of this equation, and we will get that a minus square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We will add to this equation square root of 3, and we will get that a equals to the square root of 3 units. So we found out that a equals to the square root of 3 units. Here we can write down that a equals to the square root of 3 units. Here also a equals to the square root of 3 units, and here also a equals to the square root of 3 units. So in the next step we will focus on the right triangle, triangle DEF. On the right triangle, triangle DEF, we already did this part. I will repeat on it very quickly. According to the Pythagoras theorem, PT is the Pythagoras theorem, we will get that DE square plus EB square equals to DE square plus EB square equals to DE square plus EB square equals to DB square. In the right triangle, triangle DEF, according to the Pythagoras theorem, DE square plus EB square equals to DB square. So DE square, DE equals to a, that is actually square root of 3. Square root of 3 square is 3 plus EB square. EB is the missing variable, so EB square is EB square. We leave it as it is, equals to DB square. DB is 2, so DB square is 2 square. 2 square is 4. So we found out that 3 plus EB square equals to 4. We will subtract 3 from this equation, and we will get that EB square equals to 4 minus 3 is 1. EB square equals to 1. We will take a root out of this equation, and we will get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1. We can write here that EB equals to 1, but because of the fact that the opposite sides of a rectangle are equal to each other, we will get that EB equals to DF. EB equals to DF, but EB equals to 1, so DF will be also equal to 1. And what is the value of AE? You can see easily from the drawing that AE equals to AB minus EB. I'll repeat again. AE equals to AB minus EB. So AE equals to AB, that is 4 units, minus EB, that is 1 unit. So AE equals to 4 minus 1. 4 minus 1 is 3. So AE equals to 3 units. AE equals to 3 units. So now we can easily find out the area of quadrilateral ABCD. The area of quadrilateral ABCD will be equal to the area of triangle ADE plus the area of rectangle DFBE plus the area of the right triangle, triangle DCF. I'll repeat again. The area that we are looking for, that is the area of quadrilateral ABCD, will be equal to the area of triangle ADE plus the area of rectangle DFBE plus the area of the right triangle, triangle DCF. So the area of quadrilateral ABCD equals to the area of triangle ADE. The area of triangle ADE equals to the base of the triangle, that is actually AE, times the height to the base, that is actually ED, over 2. I'll repeat again. The area of triangle ADE equals to the base, that is AE, times the height to the base, that is ED, over 2. The area of rectangle BDEF will be equal to EB times ED. The area of rectangle DFBE is the length of the triangle times the width of the triangle, is equal to the area, that is to say EB times ED, and the area of the right triangle, triangle DCF, will be equal to the base of the triangle, that is actually DF, times the height to the base, that is actually FC, over 2. I'll repeat again. The area of the right triangle, triangle DCF, equals to the base of the triangle, that is actually DF, times the height to the base, that is actually FC, over 2. Okay? And so the area of quadrilateral ABCD equals to the area of triangle ADE, that is actually AE. AE is 3 times ED is square root of 3 over 2 AE is 3 units and ED is square root of 3 over 2. So we found out that the area of triangle ADE equals to the area of triangle ADE equals to 3 times square root of 3 over 2 plus the area of rectangle DFBE, that is actually EB. EB is 1 times ED, that is actually square root of 3. So the area of rectangle DBEF equals to square root of 3 square units plus the area of triangle DCF, that is actually equals to DF is 1 times CF, that is square root of 3 over 2. So here we will multiply square root of 3 by 2 and then we will divide it by 2 in order to have a common factor with the other two expressions. So here we'll take a common factor square root of 3 from the numerator, and in the bracket we will have here 3, and from this expression we will have 2, and from this expression we will have 1, all divided by 2. That is the area of quadrilateral ABCD. So it is square root of 3. 3 plus 2 is 5, 5 plus 1 is 6. So in the numerator we have 6 over 2. 6 over 2 is 3. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the area of quadrilateral ABCD according to the second method. In the second method, we will do another construction. From point A, we will draw perpendicular to AB. So this angle will be a right angle, that is to say it will be equal to 90 degrees. And from point C, we will draw perpendicular to side CB. So this angle will be equal to 90 degrees, it is a right angle. And we will define the intersection point between the perpendicular from point A and the perpendicular from point C as point E. Point E is the intersection point between the perpendicular from point A and the perpendicular from point C. So here we created quadrilateral ABCE. In quadrilateral ABCE, we have 3 right angles, 1, 2, 3. The sum of those 3 right angles is 270 degrees, plus the size of this angle that we will define as angle X. So the sum of the angles in quadrilateral ABCE must be equal to 360 degrees according to rule number 1. We will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees, that is to say it equals to 90 degrees. So we found out that angle X is a right angle, that is to say it equals to 90 degrees. So this angle is a right angle. We will substitute X by a right angle. So you can see that quadrilateral ABCE has 4 right angles, and according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral ABCE as a rectangle. So quadrilateral ABCE is a rectangle. According to rule number 2. And according to rule number 3, the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle ABC are equal to each other. That is to say, AB equals to EC. AB equals to EC according to rule number 3. But it is given us in the question that AB equals to 4 units. Therefore, from this equation, we will derive that EC also equals to 4 units. EC equals to 4 units, so we can write here that EC equals to 4 units. Likewise, we will conclude that EC equals to AE. EC equals to AE according to rule, it is actually BC. It is BC. This is BC equals to AE. BC equals to AE according to rule number 3. And if we define BC as X, from this equation we will derive that AE also equals to X. So we can write here that AE equals to X and BC also equals to X according to our definition. In the next step, we will join together points E and D by a straight line. And we will join together points D and B by a straight line. First of all, we know that angle EAB is a right angle because we constructed it like this. We constructed it like that. We drew perpendicular from point A to AB, so this angle is a right angle. So 90 degrees minus 30 degrees will be the value of this angle. The value of this angle is 90 degrees minus 30 degrees. That is to say, it equals to 60 degrees. This angle EAD equals to 60 degrees. According to what is given us in the question, CB equals to AD. But CB equals to X according to our definition. Therefore, AD will be also equal to X. I will draw triangle AED in a new page and we will analyze triangle AD. Okay? So here, so I will draw triangle AD in a new page. So this is triangle AED. We found out that AE equals to AD, AE equals to AD equals to X, and we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles that are located in front of equal sides must be equal to each other. That is to say, this angle equals to this angle. So if we define angle AED, this angle as Y, then this angle must be also equal to y because they are equal to each other. And we know that the sum of the angles in any triangle in the world is equal to 180 degrees. That is to say, especially in triangle AD, y plus 60 degrees must be equal to 180 degrees. Y plus y is 2y plus 60 degrees equals to 180 degrees. Here we will subtract 60 degrees from this equation and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We will divide this equation by 2 and we will get that y equals to 180 degrees over 2 is 60 degrees. So we found out that angle y equals to 60 degrees. So we will substitute y by 60 degrees. So actually, triangle AED is an equilateral triangle that is to say all of its sides are equal to each other, so ED will be also equal to x and all of its angles they are equal to 60 degrees. So here we can write down that this side equals to x, this angle equals to 60 degrees, and this angle also equals to 60 degrees. So here we know that angle AEC equals to 90 degrees, according to rule number 1. So angle AD that equals to 90 degrees minus 60 degrees will be equal to this angle. That is to say, angle DEC will be equal to 90 degrees minus 60 degrees is 30 degrees. In the next step, we will prove that triangle ADB is congruent to triangle DEC. I write it down. We will prove that triangle ADB this triangle congruent to triangle EDC, this triangle. So why these two triangles congruent to each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. Those two angles, they are equal to each other, they are both equal to 30 degrees, so angle DAB is equal to angle DEC, and they are both equal to 30 degrees. Again, angle DAB equals to angle DEC equals to 30 degrees. And those two sides, they are equal to each other, they are both equal to x, so AD equals to ED equals to x. I repeat again, AD equals to ED equals to x. So we actually proved that triangle ADB, this triangle, congruent. I will remind you that this is the sign of congruent to triangle EDC according to side angle side rule. from the fact that those two triangles can go into each other, we will conclude that DC CD equals to DB, CD equals to DB, but according to what is given us in the question, CD equals to 2 units. So we can write here that CD equals to 2 units, and from this equation we will derive that DB also equals to 2 units. DB equals to 2 units. Okay, DB equals to 2 units. So in the next step, we will implement the law of cosines on triangle ADB. So I will draw triangle ADB, and we will implement the law of cosines on triangle ADB. So we have triangle ADB. So I will draw triangle ADB, and we will implement the law of cosines on triangle ADB. So this is actually triangle ADB. We will implement the law of cosines on triangle ADB. According to the law of cosines on triangle ADB, cosine 30 degrees will be equal to AD squared plus AB squared minus DB squared over 2 times AD times AB that is to say it equals to AD square is x square plus AB square is 4 square is 16 minus DB square, DB is 2, so DB square is 2 square, 2 square is 4 over 2 times AD is x and AB is 4. So here we have x squared, 16 minus 4 is 12, so it's plus 12 over 2 times 4 is 8, so here we will have 8x. So we actually got that cosine 30 degrees equals to x squared plus 8x over x squared plus 12 or 8 times x I'll repeat again. We found out that cosine 30 degrees equals to x squared plus 12 over 8x. Here we know that cosine 30 degrees equals to square root of 3 over 2, so I will write it down. Square root of 3 over 2 equals to x squared plus 12 over 8x. Here we will multiply this equation by 8x and we will get that square root of 3 over 2 times 8x equals to x squared plus 12 . 8 over 2 is 4, so we will get that 4 times square root of 3 times x equals to x squared plus 12. We will subtract 4 times square root of 4 times square root of 3x from this equation, and we will get that 4x squared plus 12 minus 4 times square root of 3x equals to 0. Here we will substitute 12 by square root of 3 squared, and we will get that x squared plus square root of 3 squared. It is actually 12 is 2 times square root of 3 squared. I repeat again, we will substitute 12 by 2 times square root of 3 squared. You can see that 2 times square root of 3 squared equals to 12. And we'll substitute 4 by 2 times 2. So it is 2 times x times 2 times square root of 3 x that equals to 0. Actually, this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3. So, according to this algebraic identity, we will get that this expression equals to a minus b squared. A is x, b is 2 times square root of 3, so a minus b, it is x minus 2 times square root of 3 square equals to 0. Here we will take a root out of this equation and we will get that x minus 2 times square root of 3, the square root of 0 is 0. We will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So actually we can substitute x, or we can write here that x equals to 2 times square root of 3 units, x equals to 2 times square root of 3 units, x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. And actually we can calculate the area of quadrilateral ABCD. Because the area of quadrilateral ABCD will be equal to the sum of the areas of triangle ADB plus the area of triangle BDC, because if you can see from the drawing, quadrilateral ABCD consists of two triangles, triangle ADB plus triangle BCD. Therefore, the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. Very simple. So we can write down that the area of quadrilateral ABCD, the squared brackets is the sign for the area. It means the area of quadrilateral ABCD will be equal to the area of triangle ADB, this triangle, plus the area of triangle BCD, this triangle. You can see that quadrilateral ABCD consists exactly those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. Very simple. Okay. Here we find out the height of this triangle. We'll draw from point D. We will draw perpendicular to the base AB. So those two angles will be equal to 90 degrees. So this is, we define the touching point between the perpendicular and AB is point S. DS is the height to the base AB of triangle ADB. So we will define it as H, and we find out the value of H. We'll focus on triangle ADS. In triangle ADS, the right triangle, triangle ADS, you can see that cosine 30 degrees, sine 30 degrees equals to H over the hypotenuse. The hypotenuse is 2 times square root of 3 units. I repeat again. In triangle ADS, sine 30 degrees equals to H over 2 times square root of 3 units. Sine 30 degrees is 1 over 2, so I write it down. We will get that 1 over 2 equals to H over 2 times square root of 3. We will cross multiply this equation and we'll get that 2 times square root of 3 over 2 equals to H. 2 over 2 is 1, so 2 will get cancelled, and we got that H equals to square root of 3 units. We found out that the height H to the base AB equals to square root of 3 units. Now it is very easy to find out the area of triangle ADB. So the area of triangle ADB will be equal to the base of the triangle that is actually AB times the height to the base that is actually H over 2. Okay, the area of triangle ADB equals to the base of the triangle that is AB times the height to the base that is H over 2. AB equals to 4 units. We found out that H equals to square root of 3 units, all divided by 2. So the area of triangle ADB will be equal to 4 over 2 is 2. So the area of triangle ADB equals to 2 times square root of 3 square units. The only thing that is left to do is to find out the area of triangle BCD. So we'll use special formula in order to find out the area of this triangle, triangle BCD. First of all, we will calculate the semi-perimeter of triangle BCD. The definition of semi-perimeter of the triangle is actually the sum of its sides over 2. So S is the abbreviation for semi-perimeter. So S equals to 2 plus 2 plus 2 times square root of 3 units, all divided by 2. Okay, the semi-perimeter of triangle ADC equals to this expression. So here 2 plus 2 is 4. 4 plus 2 times square root of 3 over 2. 4 over 2 is 2. 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle ADC equals to 2 plus square root of 3 units. And the area of triangle ADC will be equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of triangle ADC, that is actually 2 plus square root of 3 units. A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. So we get that equals the area of triangle ADC equals to S is 2 plus square root of 3 units. S minus A is 2 plus square root of 3 minus 2 is square root of 3. S minus B is also square root of 3 because A equals to B. And S minus C is 2 plus square root of 3 minus 2 times square root of 3. That is to say it equals to 2 minus square root of 3. And square root of 3 times square root of 3 is 3. Here 2 plus square root of 3 times 2 minus square root of 3. We will use the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A is 2, so A squared is 4 minus B squared. B is square root of 3, so B squared is 3. Okay, so 4 minus 3 is 1, and 3 times 1 is 3. So we found out that the area of triangle ADC is square root of 3 square units, and the area of quadrilateral ABCD is equal to the area of triangle ADB plus the area of triangle BCD. The actual triangle is triangle BCD. It's actually triangle BCD. So here we relate to triangle BCD, BDC. So the area of triangle ADB is 2 times square root of 3 square units, and the area of triangle BCD is square root of 3 units. So 2 times square root of 3 units plus 1 times square root of 3 units equals to 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD equals to 3 times square root of 3 units, 3 times square root of 3 square units. So in terms of numbers, it equals to 5.196 square units. So now I will summarize the lecture. We actually wanted to find out, or we found out, the area of quadrilateral ABCD in two different methods. In the first method, we actually found out that in the first method, we actually found out that in the first method, we make a construction from point D. We draw perpendicular to AB, so this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we focus on the right triangle ADE, sinus 30 degrees equals to DE over AD. We define DE as A. So here on triangle ADE, sinus 30 degrees equals to DE over AD. DE equals to A according to our definition, so it is sinus 30 degrees equals to A over AD. Sinus 30 degrees is 1 over 2, so we will get that 1 over 2 equals to A over AD, because multiply the equation number 1 and we got that AD equals to 2A. So we can write here that AD equals to 2A. But according to what is given us in the question, AD equals to BC. So from this equation we will derive that BC also equals to 2A. So we can write here that BC equals to 2A. And here I presented to you. So here we draw perpendicular from point D to BC. So this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay. As you can see here, quadrilateral DFBE has 3 right angles. 1, 2, 3. And then I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So if you focus on triangle DFEB, it has 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of the 4th angle that we define, this angle x, must be equal to 360 degrees according to rule number 1. 200 in quadrilateral DFBE, 270 degrees plus x must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation and we got that angle x equals to 90 degrees. So we found out that angle x equals to 90 degrees. This angle is a right angle. Therefore, in quadrilateral DEFB we have 4 right angles. And we have rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to quadrilateral DEFB that has 4 right angles if a square as a rectangle, because according to rule number 2, it must be a rectangle at least. So quadrilateral DEFB is a rectangle. And we have rule number 3 that states that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DFEB must be equal to each other. That is to say DE equals to FB. According to rule number 3, DE equals to FB, but according to our definition, DE equals to A. From this equation we derive that FB also equals to A. FB equals to A. So, what is the value of CF? You can easily see from the drawing that CB minus FB equals to CF. Again, CB minus FB equals to CF. CF equals to CB minus FB. CB equals to 2A. FB equals to A, so CF will be equal to 2A minus A is A. So we found out that CF equals to A. Then we actually connected points B and D by a straight line, and we proved that those two triangles, those two right triangles can go into each other. Why those two triangles can go into each other? That is to say, triangle DCF can go into triangle DFB. Why they can go into each other? First of all, CF equals to BF equals to A. CF equals to BF equals to A. Those two angles are also equal to each other. They are both equal to 90 degrees. So CFD equals to BFD equals to 90 degrees. And DF is a common side. It belongs to both triangles. So DF equals to itself. It's a common side that belongs to both triangles. So we actually proved that triangle DFC can go into triangle DFB according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that DC equals to DB, CD equals to, or DC equals to DB. But according to what is given us the question, DC equals to 2 units. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. Then actually I presented to you a new law. I presented to you a new law that is actually the law of cosines. The law of cosines is true in any triangle. In any triangle, if you know that the size of AB is A units, the size or the length of AC is C units, and the length of BC is B units, and the length of AB is A units, then according to the law of cosines, A squared plus B squared minus 2 times A times B times cosine theta equals to C squared. Here we subtracted C squared and added 2AB cosine theta to this equation, and we got that A squared plus B squared minus C squared equals to 2AB cosine theta. Here we divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay, it is true in any triangle. We implemented the law of cosines in our triangle. Triangle ADB. I drew triangle ADB in this page. I copied it from the original page, and this is exactly the same triangle, triangle ADB. According to the law of cosine, cosine 30 degrees will be equal to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. We know that cosine 30 degrees equals to square root of 2 over cosine 30 degrees equals to square root of 3 over 2. 2A squared is 4A squared, 4 squared is 16, And 16 minus 2 squared, it is actually 16 minus 4. 16 minus 4 is 12. So in the numerator we have in total, in conclusion, 4a squared plus 12. And in the denominator we have 2 times 4 is 8. 8 times 2a is 16a. So in the denominator we have 16a. We multiplied this equation by 16a. And we got that square root of 2, square root of 3 over 2 times 16a equals to 4a squared plus 12. 16 over 2 is 8. So we will get that 8 times square root of 3 times a equals to 4a squared plus 12. We divided this equation by 8. 8 over 4 is 2. So in this side of the equation we have 2 times square root of 3 times a equals to 4 over 4 is 1, so we get here a squared, and 12 over 4 is 3. So in conclusion, we got that 2 times square root of 3 times a equals to a squared plus 3. We subtracted 2 times square root of a from this equation, and we got that a squared plus 3 minus 2 times square root of 3 times a equals to 0. We substituted 3 by square root of 3 squared. 3 equals to square root of 3 squared. We got that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. So we can substitute this expression by a minus b squared. In our specific expression, a is equals to a and b equals to square root of 3. Therefore, a minus b will be equal to a minus b, that is square root of 3. So it is a minus square root of 3 squared, that equals to 0. We took a root out of this equation and we got that a minus square root of 3 equals to the square root of 0 is 0, so a minus square root of 3 equals to 0. We added square root of 3 to this equation and we found out that a equals to square root of 3 units. So we can write here that a equals to square root of 3 units, a equals to square root of 3 units. And then we actually proved, we focused on a triangle DEB. We implemented the Pythagoras theorem on triangle DEB. According to the Pythagoras theorem in triangle DEB, DE squared plus EB squared equals to DB squared. DE equals to square root of 3. So DE squared is square root of 3 squared. Square root of 3 squared is 3. EB squared is the missing variable, and it equals to DB squared. DB is 2, so DB squared is 2 squared. 2 squared is 4. So we got that 3 plus EB squared equals to 4. We subtracted 3 from this equation, and we got that EB squared equals to 4 minus 3 is 1. And the EB, so we took a root from this equation, and we got that EB squared equals, EB equals to the square root of 1. The square root of 1 is 1. So EB equals to 1. EB equals to 1. And because of the fact that the opposite sides of a rectangle are equal to each other, therefore DF will be also equal to 1. And what is the value of AE? From the drawing you can see easily that AB minus EB equals to AE. AE equals to AB minus EB. So AE equals to AB, that is 4, minus EB, that is 1. So AE equals to 4 minus 1. 4 minus 1 is 3, so we found out that AE equals to 3. AE equals to 3. And then we actually now can easily find out the value, the area of quadrilateral ABCD, because the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BCD. the area of quadrilateral ABCD. Actually, the area of quadrilateral ABCD equals to the area of triangle ADE plus the area of rectangle DFEB plus the area of triangle DFC, because quadrilateral ABCD consists of two triangles, triangle ADE and triangle DFC, and also rectangle DFBE. So the sum of those three areas will be equal to the area of quadrilateral ABCD. So the area of quadrilateral ABCD equals to the area of triangle ABCD plus the area of rectangle DFBE plus the area of the right triangle, triangle DCF. The area of triangle ADC, that is a right triangle, it equals to the base of the triangle, that is AE, times the height, that is ED, over 2. So it is AE times ED over 2. The area of rectangle DEBF equals to its width, that is DB, times its times DE, it is EB times DE, and so the area of rectangle DFBE equals to its length times its width, that is actually EB times ED, plus the area of the right triangle, triangle DFC. And the area of triangle DFC equals to the base of the triangle, that is DF, times the height, that is FC over 2. DF times FC over 2. AE equals to 3 units, ED equals to square root of 3 over 2. So the area of triangle ADE will be equal to 3 times square root of 3 over 2. The area of rectangle DFBE equals to EB, that is actually 2, times ED, that is AB is 1, times ED, that is square root of 3. So it is, in conclusion, the area of quadrilateral DFBE equals to square root of 3, because 1 times square root of 3 is square root of 3. And the area of the right triangle, triangle DCF equals to DF, that is actually 1, DF is 1, times FC, that is square root of 3 over 2. So here we multiplied square root of 2 by 2, and then we divided it by 2 in order to have a common factor with the other two expressions. Then we took square root of 3 as a common factor of those two expressions, and inside the brackets we will have from this expression what is left, it is actually 3. From this expression what is left, it is actually 2. And from this expression what is left, after we took square root of 3 as a common factor, what is left, it is actually 1. And in the denominator we have 2. Here 3 plus 2 is 5, 5 plus 1 is 6. So we got that the area of quadrilateral ABCD equals to square root of 3 times 6 over 2 is 3. So the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers it equals to 5.196 square units. We finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD using the second method. In the second method, we actually made another construction. We drew perpendicular from point A, we drew perpendicular to BC, so this angle is equal to 90 degrees. Then from point C we drew perpendicular to BC, so this angle will be equal to 90 degrees. and we define the intersection point between the perpendicular from A and the perpendicular from C is point E, is the intersection point. And then, as you can see, we created quadrilateral ABCE. In quadrilateral ABCE, we have three right angles, 1, 2, 3. We define this angle as x, and we know that according to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees, and especially in quadrilateral ABCE, the sum of its angles must be equal to 360 degrees. That is to say, the sum of the three angles, the three right angles, that is 270 degrees, plus the size of the fourth angle, that is angle x, must be equal to 360 degrees. We subtract the 270 degrees from this equation, and we got that angle x equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that this angle is a right angle. Therefore, in quadrilateral ABCE, we have four right angles, and any quadrilateral that has four right angles must be at least a rectangle, so we relate to quadrilateral ABCE as a rectangle, according to rule number 2. And we have also rule number 3 that states that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle ABCE must be equal to each other. That is to say, AB must be equal to EC. AB must be equal to EC according to rule number 3, but AB equals to 4 units according to what is given us in the question. So from this equation, we will derive that EC also equals to 4 units. Here, EC equals to 4 units. Likewise, according to rule number 3, BC must be also equal to AE. BC equals to AE. We define BC as x. From this equation, we will derive that AE also equals to x. So here we got that BC equals to x and AE also equals to x. Then, so here we have angle EAB is a right angle. That is to say, it equals to 90 degrees. It is given us the question that angle DAB is equal to 30 degrees. So 90 degrees minus 30 degrees is the value of angle EAD. That is to say, angle EAD equals to 60 degrees. And we also know that BC equals to AE equals to x. And it is given us the question that AD equals to BC. Here, AD equals to BC. But because of the fact that BC equals to x, then AD must be also equal to x. So in triangle ADE, we have two sides that are equal to each other, they are both equal to x. So I draw triangle ADE in a new page, and we analyze triangle ADE that has two equal sides and one angle that equals to 60 degrees. So this is triangle ADE that has two equal sides and also one angle that equals to 60 degrees. So, according to the rule that in front of equal sides in the triangle there are equal angles, those two angles must be also equal to each other because they are located in front of equal sides. So if this angle is y, then this angle must be also equal to y. So, and the sum of the angles in any triangle equals to 180 degrees. That is to say, y plus 60 degrees must be equal to 180 degrees. That is to say, y plus y is 2y, and 2y plus 60 degrees equals to 180 degrees. We subtracted 60 degrees from this equation, and we got that 2y equals to 180 degrees minus 60 degrees is 120 degrees. 2y equals to 120 degrees. We divided this equation by 2, and we got that the value of angle y is 180 degrees over 2 is 60 degrees. So this angle equals to 60 degrees, and this angle equals to 60 degrees. So all the angles inside triangle EDA are equal to 60 degrees. Therefore, triangle EDA is an equilateral triangle, and A equals to X, AD equals to X, so ED must be also equal to X because all the sides of equilateral triangle are equal to each other. So in the original drawing, we can write that ED equals to X, this angle equals to 60 degrees, and this angle also equals to 60 degrees. And this angle equals to 60 degrees, and angle AEC equals to 90 degrees. So what is the value of angle CED? The value of angle CD equals to 90 degrees minus 60 degrees. That is to say, the value of this angle, angle DEC, is equal to 30 degrees. Then we proved that those two triangles can go into each other. Why those two triangles can go into each other? That is to say, triangle ADB and triangle EDC can go into each other. Why they can go into each other? First of all, AB equals to EC equals to 4 units. Here, AB equals to EC equals to 4 units. Those two angles, they are both equal to 30 degrees, therefore they are equal to each other. Angle DAB equals to angle DEC equals to 30 degrees. AD equals to ED equals to X. AD equals to ED equals to X. So we found out that triangle ADB can go into triangle EDC according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that CD equals to BD according to the rule that corresponding sides in congruent triangles are equal to each other. But it is given us the question that CD equals to 2 units. CD equals to 2 units. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. Now we can implement the law of cosines on triangle ADB. So I drew triangle ADB in a new page, and we implemented the law of cosines on this triangle, triangle ADB. We know that AD equals to X, DB equals to 2, and AB equals to 4 units, and this angle DAB equals to 40 degrees. So according to the law of cosines, cosine 30 degrees equals to AD square plus AB square minus BD square over 2 times AD times AB. AD is X, so AD square is X square. AB is 4, so AB square is 16, because 4 square is 16. DB is 2, so DB square is 2 square. 2 square is 4 over 2 times AD is X, and AB is 4, so it is 2 times X times 4. Here X square plus 16. 16 minus 4 is 12, so in the numerator we have X squared plus 12. In the denominator we have 2 times 4 is 8, so it is 8 times X. So we got that cosine 30 degrees equals to X squared plus 12 over 8X. Cosine 30 degrees equals to X squared plus 12 over 8 squared over 8x. We know that cosine 30 degrees equals to square root of 3 over 2. And here we have x squared plus 12 over 8 squared. We multiplied this equation by 8x, and we got that square root of 3 over 2 times 8x equals to x squared plus 12. Here 8 over 2 is 4, so in this side of the equation we have 4 times 3, 4 times square root of 3x equals to x squared plus 12. So here we subtracted 4 times square root of 3x from this equation, and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. We substituted 12 by 2 times square root of 3 square, because 2 times square root of 3 square equals to 12. And we got that x squared plus 2 times square root of 3 square minus 2 times x times 2 times square root of 3 times x equals to 0. This equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression a equals to x and b equals to 2 times square root of 3. So we can substitute this expression by a minus b squared according to this algebraic identity. So we did it and we got that a minus b squared, it is actually x minus 2 times square root of 3 squared, that equals to 0. We took a root out of this equation and we got that x minus 2 times square root of 3 equals to 0 because the square root of 0 is 0. We added 2 times square root of 3 to this equation and we got that x equals to 2 times square root of 3. So we can write here that x equals to 2 times square root of 3, at x equals to 2 times square root of 3, and x equals to 2 times square root of 3, and also here x equals to 2 times square root of 3. Now it is very easy to calculate the area of quadrilateral ABCD, because the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC, because of the fact that quadrilateral ABCD consists of exactly those two triangles. Therefore, the sum of the areas of those two triangles will be equal to the area of triangle ABCD. Will be equal to the area of quadrilateral ABCD. The area of quadrilateral ABCD that consists of two triangles will be equal to the area of triangle ADB plus the area of triangle BCD. Here, in order to calculate the area of triangle ADB, we calculated the height. From point D we draw perpendicular to AB, so this angle equals to 90 degrees and this angle equals to 90 degrees. In triangle ADS, sin 30 degrees equals to h over 2 times square root of 3. Sin 30 degrees equals to h over 2 times square root of 3. We know that sin 30 degrees equals to 1 over 2, so 1 over 2 equals to h over 2 times square root of 2. We multiply this equation by 2 times square root of 3, and we got that h equals to 2 times square root of 4, so 2 times square root of 3 over 2, 2 over 2 is 1, so we found out that the value of the height of triangle ABC h equals to square root of 2. Now it is very easy to calculate the area of triangle AB. The area of triangle ADB equals to the base of the triangle, that is AB, times the height over 2. The base AB equals to 4 units, the height h equals to square root of 3 units. So 4 times square root of 3 over 2 is the area of triangle ADB. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 square units. And the only thing that is left to do is to find out the area of this triangle, triangle BCD. And we use a special formula in order to find out the area of triangle BCD. First of all, we calculated the value of the semi-perimeter of triangle BCD. The semi-perimeter of triangle BCD equals to the sum of its sides over 2. The sum of its sides is A equals to 2, B equals to 2, and C equals to 2 times square root of 3. So plus 2 plus 2 is 4, plus 2 times square root of 2 over 2. 2 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle ADC is equal to 2 plus square root of 3 units. And we know that A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. And the area of triangle ADC will be calculated according to this formula, that equals to the square root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of triangle ADC, that equals to 2 plus square root of 3 units, and A, B, and C are the length of the triangle ADC. So we put the data inside this equation, and we got that S is 2 plus square root of 3 units. S minus A, it is actually 2 plus square root of 3 minus 2 is square root of 3. S minus B is the same because A equals to B, it is also square root of 3. And S minus C, S is 2 plus square root of 3, minus C, that is 2 times square root of 3. And it equals to 2 minus square root of 3. Here, square root of 3 times square root of 3 is 3. And 2 plus square root of 4, 2 plus square root of 3 times 2 minus square root of 3, it is actually A plus B times A minus B. And according to the algebraic identity, that A plus B times A minus B equals to A squared minus B squared. Here A equals to 2, so A squared is 2 squared, 2 squared is 4, minus B squared. B is square root of 3, so B squared is 3. So we got here 4 minus 3, 4 minus 3 is 1, and 1 times 3 is 3. So we found out that the area of triangle ADC equals to square root of 3 square units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BCD. The area of triangle ADB is equal to 2 times square root of 3 square units, and the area of triangle BCD equals to square root of 3 square units. 2 times square root of 3 units plus 1 times square root of 3 units equals to 3 times square root of 3 units. Therefore, we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. Okay, so we found out on both methods that the area of triangle of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, thank you very much.